Hello, everyone. My name is Tanusree Sharma, PhD candidate in informatics at University of Illinois at Urbana-Champaign. I'm delighted to be here today alongside with my colleagues to present our research on disability-first design and creation of a dataset showing private visual information collected with people who are blind. As we delve into more details on the motivation, method, and findings, I invite my colleagues to join me. Abby, over to you.
Thanks, Tanusree. My name is Abigale Stangl. I'm an NSF CRA Computing Innovation Fellow working in human-centered design and engineering at the University of Washington. Lotus, will you go next?
Thanks, Abby and Tanusree. My name is Lotus Zhang. I'm a PhD candidate, also from the Human-Centered Design and Engineering Department at UW. Everly, would you like to jump in for introduction?
Thank you, Lotus. My name is Everly Tseng, a PhD student working in computer vision at the University of Colorado Boulder.
This project is a part of our bigger umbrella of NSF-funded project involving multiple universities. We're trying to solve a problem that can make visual content sharing safer for blind users in a socio-technical approach.
So the key challenge that we're trying to address in this project is that people who are blind take and share images and videos with their peers on social media, with visual assistance technology and beyond, but it's hard for them to non-visually detect private visual content in those images. So to address this challenge, we considered the resources needed to train systems to automatically detect private visual content in these images. Everly, will you provide additional details on the limitations of the existing dataset for our purposes?
So there are existing crowdsourcing methods, but there's limitations upon collecting visual data that contain private information. Ethical issues occur if we apply existing crowdsourcing methods, and our target here is to propose a new method to collect private visual data captured by blind users.
So in order to build an algorithm that detects private content from blind users' images and videos, we need an inclusive dataset that is representative of the photography skills of blind users, because the characteristics of images and videos captured by blind user can be quite different than sighted users. The lighting can be different and the angle and size of the object can be different. So our goal for this discussion is to show how can we generate such a dataset to support novel algorithm development while protecting our blind users' privacy.
So we delve into this broad research question by looking from two angles. First, methodologically, how can we create a dataset of private visual content captured by blind users in a privacy-preserving way? Second, from blind people's perspectives, how do they think about the liabilities and opportunities with contributing images and videos they captured to a public dataset that can support the development of privacy-preserving tools? To explore these research questions, we came up with an ethical and accessible private data collection method and probed for blind participants' response. More specifically, to protect the privacy of blind participants, we created a set of prop objects, meaning fabricated objects that do not contain any real personal information, instead of asking blind participants to capture images or videos of their own objects. We sent out a kit of 14 prop objects to participants, containing financial, medical, sexual health-related objects, as well as any other personal objects with identifiable information. Objects were all attached with a QR code and a Braille label that participants can use to access the object names.
For this project, participants also got a data collection infrastructure called BIV-Priv app that helped them identify those prop objects by either QR code or Braille label and perform photography of those objects and share with us in a privacy-preserving manner.
So once a participant captured an image or a video using the app, we reviewed the content to make sure it met 3 criteria. First, there was no real private content from the participants in those images or videos. Second, the propped objects would be in the images and videos, not out of frame, for example. And third, that the videos were at least 25 seconds long. So To recruit our participants, we first disseminated an anonymous survey to recruit a pool. And in this survey, we asked potential participants about their willingness to take images and videos to share with the research team and for the purpose of building a disability-first data set. We wanted to make sure that they were aware of this from the outset. In the end, we ended up recruiting for 26 participants, 70 of which were blind from birth and 30% of which had acquired blindness.
And for the data collection part, we asked the participants to capture the data using our app. Before the data of prop objects were collected, we performed a Zoom session to go through an example with the participants using another object so that they can get familiar with the process. Then the participants work on the real tasks offline.
We also interviewed participants to gather their experience, challenges, and suggestions on taking and sharing visual content that aligning with their values. And as for the analysis, we performed a thematic analysis for the qualitative data, and we also pre-processed the video and images data. So during our data collection process, we had 3 primary design considerations. Firstly, we ensured that we did not collect real private visual data from our participant. Secondly, we evaluated the potential risk for both participants and researcher associated with the private prop object making. Lastly, we ensured that our research process is accessible.
So creating the 14 prop objects was a careful and really tricky process that involved balancing between making sure that no real private information is involved and that the prop objects are still representative to real private ones. For example, in selecting prop objects' appearance and content, we researched common visual features of different private objects and also used online templates as well as random information generators to produce the fabricated prop objects. We made sure that there are 3 to 5 variations of each prop object to cover diverse instances. We also did a final check to make sure that the fabricated objects make sense and none of them have personal information that actually match a real person's.
As Lotus was just saying, part of this process was assessing risk, making sure that we weren't going to disclose any real private information, as well as consider the risks that we as researchers would face while making this content. For example, we didn't want to break the law by fabricating state IDs or social security cards, as even though people who are blind have considered these as private visual content in prior work.
Another key design is accessibility for prop distribution, data collection, and photography task instruction. For packaging and distribution, we created QR code and braille level with each of the object name. This allows participants to have the flexibility to recognize the objects with either option within the app. We also created a photography instruction accessible in a website.
So now we would like to talk about the data set itself. Eventually, we were able to collect 14 object categories with a total of 728 images and 728 videos captured by 26 participants. All videos are at least 20 seconds long. We are able to observe some features in the data, such as upside-down papers, objects partially in frame, some lighting issues, and blurriness. These interesting features are unique to data collected by blind users.
So on the final note, this project has 3 main contributions. Our project contributes a method of ethically creating dataset with blind users with an aim to support the development of AI tools.
And for the computer vision community, this project provides access to private visual data where images and videos are taken by people with visual impairments. The unique features of the data allows the community to expand both algorithms and benchmarks to this unexplored area.
Finally, from the human-centered design perspectives, our project explored how to design the procedures and artifacts involved in supporting blind people in contributing visual data, as well as their perspectives towards such tasks.
For further information, feel free to reach out to us. Thank you.